These war stories from Ivan and the dinosaur. We're going to have some more now. So I'm going to hand over to Josh Dvir, who's going to talk about managing applications with Kubernetes, Kops and Terraform. Thank you.
Thank you.
Yes.
So I'm Josh. I'm working in DevOps Pro. We're a consultancy, surprisingly DevOps consultancy, and we help our clients deliver faster. So I'll try not to say Kubernetes a lot today. I'll use the word cluster. So if I say cluster, you know it's Kubernetes. Does anyone here doesn't know what Kubernetes is? Good. So I'm going to talk about it. So a couple of words on Kops, Terraform, and then I'm going to show a real production environment for a client that we built. We built a full infrastructure for them. I'm probably going to manage only the support cluster, and I'll explain what's the difference between the support and the environment. So let's get Kubernetes. So Kops. In 2 words, Kops help us manage Kubernetes clusters. That's it. Create, destroy, upgrade, everything that comes with managing. Terraform. Terraform helps us provision infrastructure, different clouds. That's basically it. Now, so you don't say anything, just say it. Now, it's going to be an informal presentation. I don't have any slides. I just want to try to deliver the thinking process that I have when I built this thing. So, but before I start, the infrastructure for the client, we divided it into two types of clusters. One is the support cluster, and the other one is the environment cluster. So, what's the difference between them? The support cluster, which we call in tools, it contains all the supporting tools that the applications need. Now, they don't contain like databases and things like that. They contain like Docker registry, they contain the CI server, they contain all the supporting environment that the applications need. Like, for example, if in all of my clusters I have FileBeat to send all of the logs into Redis, and from Redis I pull them into Logstash, and from there to Elasticsearch. So Logstash is in this cluster, and Redis is in this cluster. These are the supporting things that I use for my applications. And the applications cluster contains all the application stuff for the applications. Their databases, their Redises, Memcache, everything that's related. That cluster I won't be able to show today because it has all the applications of the client. So we'll focus on the supporting cluster. And they're both built using the same structure, same thinking behind them, and that's the difference between them. So when I'm talking about an infrastructure that I want to build, it's not only the cluster itself. The cluster for me, it's a way to put my application inside of it. That's the only thing it does. And I usually don't put any databases inside Kubernetes because its persistency is flaky sometimes, and it takes a while to get used to it, and I still don't trust Docker with my database. And so most of my databases, if I'm on AWS, they're in RDS. Same goes for Redis. So usually my cluster contains things that are flexible to me. Flexible means I can kill a cluster and bring up a new one because I don't care about that cluster. That's what Kubernetes cluster means to me. Now, but still, the infrastructure needs to be stable. I need to have some things that are static, like IP addresses, like CIDRs, subnets, things like that. So, thankfully, we have Kops. So Kops help us deploy the Kubernetes cluster inside of AWS, and it can do everything for us. It can build the VPC. It can do all the subnetting. It can provision the autoscaling and bring up the nodes. It can do everything for us. It's good that we can do all that, but still, as I said, I want to be able to remove the cluster and bring up a new one. one of the issues with Kubernetes sometimes is, well, they release quick, very, very quick. You see there was 1.7, I think 3 months ago. 1.8 is coming this coming week or this coming month. So they're releasing very, very quickly. And upgrading cluster can be very daunting. It's not an easy task to do. So sometimes you have to kill a cluster and bring up a new one with everything inside of it. And that's why the way I create the infrastructure, I use Terraform. So Terraform for me creates all the RDSs, creates all the Redises, it creates all the VPC. It creates the VPC and inside that VPC I have a subnet division. So I have private subnets, database subnets, Elasticsearch subnets, public ones. Now in these subnets, I usually deploy all the databases and the Redises. And even if there is a VPN that I want to bring in, I will deploy it in this environment. Because I don't want it as part of the Kubernetes. Because VPN for me is something stable, that should be stable, we don't need to change it every day, and Kubernetes does. I want to be able to remove the cluster and bring up a new one. So Terraform builds everything that supports Kubernetes. It supports the Kubernetes cluster. And for that, I use Terraform. Yeah. So the structure of the folders, the config basically contains the configuration of the cluster. This is a Kops configuration file. It basically says which subnets, which IP addresses, auto-scaling group names. There is a division for the nodes and the masters, how many masters, in which availability zone. Everything is inside of that config file and inside that folder. And now the structure you see here, we built a Docker image that supports that structure, which means there is a bash script that says, right, first go to the config folder and bring up a new cluster using Kops, using that config file. Afterwards, go into the ingresses folder and just apply everything inside that folder. And that way it goes, one by one, the same structure. So, moving to the next folder, the ingresses. And ingress controller in Kubernetes, everyone knows. I'm using Traffic. I found it a lot more nice to use than Nginx. It's Go-based, and I really enjoy it. And as I said, the script just goes and deploys Traffic and deploys the ingress for me. Afterwards, the PVs, if I use them, here I do, which is the persistent volumes inside of Kubernetes. Since I'm using Kops, they will create an EBS volume, and they're not attached at the moment. We're just creating them here. Secrets, if I have them. I usually use secrets just to save credentials for Vault, and even spoke about it before. I do use Vault. The reason I use Vault is not to keep secrets, really. It's just for me to give the developers the power with their environment variables that they need. So in the Kubernetes secrets, there is a user and a password that it has README access to a specific secret inside of Vault. And the Vault contains all the secrets that their application needs. So if they want to change some environment variable, they just go to Vault, and they have a Slack bot, and they can restart all the containers, and Vault, and their application pulls from Vault as soon as it brings up. So secrets in Kubernetes, for me, they're not secrets in Kubernetes because they're base 64 and everyone can decrypt them. So Vault saves all the secrets, and inside of Kubernetes there is only read-only users for Vault. I'm going to skip services for a second. And templates, it's a folder that has the YAML file for Kops to create everything I showed before. So services. So in our supporting cluster, we use many services. Some of them are Kubernetes specific like the autoscaler, AWS autoscaler, which basically says, which basically we're configured it to be attached to the autoscaling group, and it knows how many pods there are, how many we want them to be, and if the number of nodes is not enough, it will go to the autoscaling group and bring up more nodes or reduce the nodes. Claire is a project from CoreOS. What it does is scan Docker images for security vulnerabilities. So it's part of our CI process. For every Docker image that we create, we run Claire on it, and they give you results starting from high, medium, and low. And based on the number of violations, we decide if we want to deploy the Docker image or we don't. Sometimes the fixes are OS-based, sometimes they're application. But what Claire does is scan all the layers in the Docker image and brings up the results. And other services delete the AWS indexes, basically. And so there was a problem with the AWS Elasticsearch 5.1 that Curator is a tool by Elastic that manages Elasticsearch indexes or the cluster itself. So in AWS Elasticsearch 5.1, we weren't able to use Curator to delete indexes. And the logs, they were filling up, and we didn't want to provision more instances for it. So because they're only logs, and we don't want to keep them more than a week. So we created a small Go application, then we deployed it into our tools. And not on the application, because Elasticsearch is part of the supporting tools for the applications. Deployer, it's also our own application. It's a Slack bot and an API tool that basically we just do a CRO request to the deployer, and we tell him which application deploy to which cluster and which environment. And we just deploy it for us. It just changes the deployment with a new image, and we're doing rolling updates. And Docker cleanup, it just removes Docker images from the nodes that aren't being used. And drone. Anyone knows what drone is?
CI?
Good, CI. Is it better than Jenkins?
No.
Much better, good. So, well, my relationship with Jenkins is very, very complex. I hate it. So, yeah. So I've been using drone for more than 2 years. It's a CI based on Docker, completely on Docker. And everything you do there, it's inside of an image. So I enjoy it very much. So drone is our CI, and we have the agents there. And drone wall is just a TV dashboard, so everyone can see who's leading with the commits number or the build number. And afterwards we have FileBeat. FileBeat it's a log shipper. It's just attached into FileBeat runs on every node, and it just tails all the log files and ship them into Redis. From Redis we have Logstash here that pulls all the logs and send them into Elasticsearch. That's my flow. I found Elastic Proxy. We're using elastic.co, Elasticsearch now, and they have ugly URLs, so we created a proxy to make them nice. Kube state metrics, it's a metric. It exposes Kubernetes metrics for Prometheus. If you ever wanna do that, then you should. Nexus. It's a Docker registry, and it also provides Ruby registry for gems and Pip and NPM. It's a good tool. We've been using it. PG Web, it's a web interface for Postgres. All of these services are usually behind firewall, so they're not accessible via the internet. So we allow ourselves to put on tools that aren't secure, and the client is not an enterprise kind of. So this tool basically brings up Postgres UI that I can access to it and just see the tables, the indexes, things like that, things that change. Prometheus. Every Kubernetes cluster has its own internal Prometheus, and we have an external Prometheus that is not connected into any Kubernetes. We have an external Prometheus that is deployed in ECS, and that Prometheus connects to all clusters Prometheus and pulls all the metrics from them and save them inside of them. And the reason I created it, because it's a monitoring solution, and if I would put him inside of a Kubernetes cluster and that cluster would crash, I don't have any monitoring anymore. So that's why it's sitting far, far away in ECS, which is a AWS container solution. But every cluster has its own Prometheus, and that's being queried for metrics. Never mind, that's for refresher. So yesterday I deployed Sentry. Sentry is an exception handler that is compatible with 30 programming languages. They all have agents, and you just connect it to your application, and every exception that happens in your application, it just ships it into Sentry and just gives you a nice UI. And we have Sentry Kubernetes, which is the Kubernetes agent for Sentry. And ever since I deployed it, I felt sorry, because I saw everything Kubernetes but fails. And yeah, it was just sad. After that, we have Snapbacks. It's the way we move secrets inside the organization. I know it's hard to change people, but it's hard when it's something that's important. But it's easy when it's something that's important to them. So usually the way they moved secrets was in emails, and we brought in a solution that basically, since it's deployed in our cluster and it's in our control, it's connected to Redis, and it gives you a box. Let's see if I have it. So it just gives you a box. You can put every secret you want here, and you just generate a one-time URL. So I just click on the generate URL, and then I copy it, and once I open it, it's deleted from Redis, and it's not available anymore. So if I refresh it, you see it's not found. And that's, ever since we brought them this tool, they've been using it like crazy to share information. Yeah, because they understood that email is not the way. Lucky for us. Spinnaker, we deployed Spinnaker, I think, a month and a half ago. We haven't been using it yet. It had a problem. It's been bombing GitHub API, and we've been violating their limits all the time using Spinnaker. And it was a bug that was just been fixed this week. We've been upgraded, and now we're gonna bring him in. The reason we wanted Spinnaker and not Easter, for example, first, the complexity. Spinnaker, for our opinion, is simpler. We don't do service discovery. It's not in our vocabulary at all. I do service discovery the old way. Every service has its own domain, subdomain, path-based URL, whatever. And you just have to go to the closest DNS to get the address, to get the IP, and it's all behind load balancers. So we don't have console, we don't have etcd, things like that. So we don't have any service discovery in that sense. CSPAS, it's an application written in PHP to save passwords, upsource, code reviews, and Vault and Vault UI. Vault UI just gives the UI to the developers, gives them the power to change their environment variables inside of Vault. Now, who here gives the developers the power, the full power on their applications? I mean, they can deploy at any time they want. less than a few people, less than 5, I think. So, in my perspective, the developers, once they have the full control, they are the ones who are responsible for their application, from start to bottom. And you want them to be responsible. Otherwise, you won't sleep at night. And that's my motto, I sleep at night. And my other motto is do things simple. Usually, the clients I work with, this is the first client that is considered, SMB for me. It's a company with 500 people, and they're not big, but it's my biggest client, my biggest company that I work with. I usually work with startups that don't have any resources for DevOps, and they want a good solution that scales, because usually startups can boom scaling-wise, and they don't want to manage anything on their own. So my solutions are always simple. That's why I use drone, because once I deployed it, the developers themselves started adding their applications to drone, because it's far simpler than Jenkins pipelines, far simpler. And they're happy with it. I don't need to manage any drone. It didn't crash, not even once. And it's something I can't say for Jenkins. And my setup with Jenkins was every time there is a build, you create a new pod and you run the build inside that pod. Surprisingly, the plugin was half maintained, wasn't fully baked, and crashed a lot, and it didn't really work. So moving to drone just made my life simple, and that's something I try to do all the time. Make my life simple. I think that's it. If you have any questions, yeah. Right. Okay. Yeah.
Maybe I missed it. Where do you store the Docker images?
In Nexus. Nexus is a Docker registry, as well as this one.
Oh, yeah.
Yeah. It's a Docker registry, a Ruby gems, pip, and npm. Yeah.
Obviously, a lot of your stuff is deployed on AWS. Why did you choose to use Elastic's hosting service for Elasticsearch rather than the AWS Elasticsearch service?
Well, some things aren't in my control, sadly. The version that comes with AWS Elasticsearch, the Kibana version, is not the latest. And some people are spoiled. They want the latest. And Elastico provides the latest Kibana. Even though I could have created a Kibana inside the cluster and just connected to the Elasticsearch, but no, it wasn't good enough. So yeah, that's the reason. Kibana is the latest in Elastic.
Okay, cool. Final question from Mr. B.
Hi, I don't run Kubernetes or use Kops, so sorry if this is a bit a basic question. You mentioned at the beginning of the talk that you migrate between different clusters of Kubernetes over time, and that's why you have like Terraform separating some stuff from the Kubernetes. How do you kind of like migrate over, this is all the stuff running in one cluster to the other cluster? Is that handled by Kops, or is that something that you've had to deal with yourself?
Yeah, Kops as its own has the option of migrating services between clusters. I don't do that. Since everything is always in files, I just run, and I have a Docker image that runs in a certain order. I just runs it and make sure it runs. Because if it doesn't work, then my setup is not good. I see it the same as database restore. A database restore isn't real unless you try it. So the same thing goes here.
Awesome, Josh. Thank you very much.